Okay, so I figured it out. These individuals, I must have pushed a button somewhere. These individuals here, the p squared ones, were back. Were homozygous for the trait. But they're dominant. They have the dominant allele. So in other words, they have 3 toes, I guess. I'm not a turkey expert. These guys have 3 toes. These guys have 3 toes. And only these q squared have the 4 toes. So why do we start with q squared every time? We start with them because we can look at them. They're different genetically. All right. Where do we go with that? So this is me testing out my pencil here. So we start with q squared. And so so here we just have to do some plugging, and that gives us how this is done as far as the math goes. So we know we're going to start with q squared, the frequency of our recessive individuals. And so we said earlier that frequency from our conversation was 25%. And so 25% in decimals is 0.25. So I know that. Well, the next thing I need to figure out is Q. Well, why do I need to figure it out? Whoops. I need to figure it out because it's the easiest thing to do. To go from Q squared to Q, I just take the square root, and I take the square root of 0.25, and that ends up being 0.5, because 5 times 5 is 25. And so I've gone from q squared to q. All right, now from here, right, the next thing I'm going to do is I'm going to go to p. How do I solve for p? Well, we said earlier that our equation p plus q equals 1. P plus q equals 1. Well, what's the other part of this? Something plus q equals 1, so it must be also 0.5 in this example. All right, well, this is turning out nicely the way our numbers are working. And so p squared would also be 0.25, and then 2pq. This one's a little trickier. There's 2 ways to get 2pq. One way is to go back to that equation p squared plus 2pq plus q squared equals 1. And I know 2 of those 3 things. I know my p squared and I know my q squared. And those together add up to 0.5. So 2pq must equal 0.5 as well, because that's the only way I'm going to get to 1. All right, the other way to do that is 2 times p times q. Well, I want to get 2 times p times q. That's 2 times 0.5, right? Which is 1 times 0.5, because that's the q part, would be 0.5. And we're done with that. And that's how you solve Hardy Weinberg problems. So what I'm going to ask you to do, just for giggles, is to solve this problem with squirrels. And the squirrels are going to have a trait which is a skinny tail. And the skinny tail trait, we're going to say we find it in, let's make our numbers a little trickier. Let's say we find it in 16% of individuals. 16% of individual squirrels in the town of, let's see, what's a fun town? Rehoboth, Massachusetts, are going to have a skinny tail. Okay, so I'm going to ask you guys to go ahead on this one, and you can post your answer on Google Classroom in the comments if you'd like. Or you can email it to me, or just see what you can do with it. Have a great day, everybody. Remember, wash your hands, and continue being awesome. And take care.